All right. Fairly full house. Thanks for coming. So, my name is Evan. I do visuals for touring bands and all kinds of things for the last decade or so. Mostly in the US, and more so here in Europe, across Europe, currently living in Berlin under the name CINEMA.AV. Like I said, I'm kind of committed to video art in this really strange way that is kind of not normal and often not quite healthy, to the point where, like, okay, so today is a really good example of that. I work for Sleepy Circuits in tech support, and I manage all of our social media platforms and all that jazz. So, and obviously we're over at Table 91, right next to our dear friends Syntony, displaying a video synthesizer that we sell called Hypno, which is a standalone, all-in-one kind of video instrument, 2 oscillators and a video feedback engine, all that jazz, kind of wrapped into one. And then, later tonight, I'm doing visuals for Lick Mum No Computer on the live stage, if you will. And I just flew in like late last night. So I do these workshops and I do these things, these sort of educational methods. I mean, I've done them a lot in the spring for Schneidersladen in Berlin. Did a whole 6-week series, and have since done a couple of other things across Germany, and teaching another one in Todmorden, just outside of Manchester, in 2 weeks. So I do video synthesis for a living and for a lifestyle that, like I said. But today we're going to talk about audio visualization. The theme is kind of objects in motion. We've lost some. Oh, the mic's there. Okay, cool. I just don't speak very loud. Title's called Objects in Motion. I'm going to show you guys all about audio reactivity and audio visualization for playing with bands and playing with musicians. Because you can do video art all day long by yourself in your room and live a very comfortable life in that headspace. However, though, it's not when you go out into the world and realize that things fuck up and make mistakes. You make mistakes. You forget how to operate your equipment. You forget to eat sometimes. Your brain kind of goes other places. Maybe the musician you're playing with also disappears into a very similar headspace, and things just go pear-shaped. However, though, sometimes you're able to kind of bounce around and recover from these sorts of things. And so I'm going to show you all sorts of methods of fumbling and making something really pretty out of this total chaos and destruction. But before we do any of that, I actually want to show. I want a show of hands. Who knows about video synthesizers? Just a handful. Okay. Do you guys want to know about video synthesizers? Yeah? Sure. I'll take that as a yes. Amazing. So I'm going to pull up a little video primer to get you guys going.
Welcome to the LZX Industries primer on analog video. Our goal with this video is to establish a basic familiarity with the analog video signal and its component parts. Digital video is composed of a sequence of still images known as frames. Each frame is a two-dimensional grid of colored pixels. When we manipulate and display digital images, we are dealing with an entire picture all at once. In this respect, digital video is most analogous to the individual exposures in a strip of film. The analog video signal is more analogous to an audio signal. It is a continuously flowing intensity across time. When an analog signal controls the electron beam of a television, the resulting fluctuations in light are perceived by our eyes as a moving image. The value of an analog signal is measured in volts. Voltage is measured across time, and the speed at which voltage changes is known as the signal's frequency. But we are missing some pieces of the puzzle. The television needs more information to know when to sweep the beam across the display and when to return the beam to its starting position. This information is given to the television in the form of video sync pulses. Let's take a closer look at the video signal by transforming this sine wave into something we can display properly on a television. The basic unit of measurement in analog video is called the scan line. One scan line is defined by the time it takes the television beam to move from the left edge of the display to the right edge of the display and back again. In the case of this sine wave, we see multiple repetitions, so that means the sine wave's frequency is faster than the scan line rate. The first processing step we need to perform is black level clipping. Next, we do the same thing with our white level. Voltages outside of this brightness range may cause the display to malfunction. Finally, we are going to add a sync pulse to the beginning of our scan line. This pulse will tell the television that a new scan line has begun. In the LZX modular video synthesizer, the color video encoder module performs all of these conditioning operations behind the scenes. The video output of this module is always valid video, which can be displayed and recorded. Now that we have a proper video scan line, let's see how it is displayed. Only a portion of the video signal is viewable on the display. The horizontal blanking interval is outside this active video area. There are 45 blank scan lines which are not displayed in the active video area. Let's look at the first active video scan line. The electron beam of the television starts on the left and moves to the right. The brightness of the beam changes in response to the voltage level of the video signal. At the end of each scan line, the horizontal sync pulse instructs the display to turn off the beam and move it back to the left side of the display. There are 480 active scan lines in each video frame. The total number of active scan lines is known as the video's vertical resolution. Horizontal resolution is not determined by discrete units like scan lines or pixels, but instead by the bandwidth of the analog system. For each complete frame, there are two interlaced fields, displayed one after the other. The first field is the odd field, because it contains all of the odd-numbered scan lines. The second field is the even field. In between the active scan lines of each field, we have vertical sync, or the field rate. This signal instructs the display to turn off the beam and return to the top of the display. There is a final sync signal we'll discuss in this video, and that is the odd-even gate, or the frame rate clock. The frame rate frequency is roughly 30 frames per second. Let's review our other two video sync signals in relation to the frame rate's timeline. Next is the vertical sync pulse, or field rate. This pulse instructs the display to return to the top in order to display a new field. Finally, we have our horizontal sync pulse, or line rate. This pulse instructs the display to return to the left in order to display a new scan line. Don't be overwhelmed by trying to memorize any of these exact numbers or frequencies. The most important concept is to understand what these signals do and how they relate to each other in time.
Cool. So that's an old favorite of mine, largely because I find that music super therapeutic, and it reminds me a lot of this old this VHS I had as a kid. It was how to install a fish tank, and for some reason I remember the music sounding very, very much like that. But yeah, this was the LZX video primer, kind of showing you guys all about kind of basic video synchronization and how these sorts of very complex signals work on a raster display. However, all of these modules are very well discontinued, but the device I'm going to show you guys mostly today is called Hypno, and it is largely based on those original circuits. And as you can see, it's up on screen right now doing some really light video sampling and shape generation. I can just give you guys something very simple and some boring lines. No, you guys get diamonds today. You guys don't get lines, which is fine. Actually, maybe give you guys a line. Yeah, there you go. You get a line. Cool. Great. You get a line. Cool. And just like we saw on screen just now, make that line any which color we want. So, yeah, that's a really good place to start. So, excuse me, that's a little distorted. But what was I going to say? So yeah, we've got a really basic video synthesizer. It can be really complicated, however you like. What's next? So let me turn the audio down. So yeah. Oh shit, we just did that. Come on. There we go. So on the subject of audio visualization, um, I'll show you guys another example from the 70s. Stephen Beck, a video artist who developed his own video synthesizer using some university money, a university grant actually, and an artist called Warner Jepson, who is famous for using the Buchla 200 series of modular synthesizers, did this small performance, maybe early to mid 70s, and it was kind of this and the next example I'm going to show you guys are kind of the earliest kind of motions in audio visualization, using like an audio performer to work with a video performer. We kind of think of it now as like I feel like to some degree it's like people really want to try and synchronize their visuals super tight, but we don't really understand to some degree where that comes from. And to see a really primitive example like this, it's more of two artists kind of jamming together in the same way that like nothing is like directly tight, but it's like loose in this way that feels very human and very organic. And I think there's a lot to be said about that, because I mean, yeah, you can go the really tight, like crazy sync pulse route, or you can just jam and feel free to like do your own kind of thing. And so I'll show you guys that just very quickly.
This is Stephen Beck, and this is Warner Jepson. They are artists at the National Center for Experiments in Television, an affiliate of KQED. The instruments they use are sophisticated electronic devices which create pictures and sounds. One, the Beck Direct Video Synthesizer, was designed and built by Stephen Beck. It alone generates the forms, textures, and colors you will see, and needs no cameras to make a picture. The image is controlled precisely by the artist, by manipulating knobs, switches, and dials as he performs his composition. In the same way, the Buchla audio synthesizer allows composer Warner Jepson to generate forms, textures, and colors in sound. Infinite possibilities of pitch and rhythm make new sound, images, and shapes. Stephen Beck and Warner Jepson have performed a series of duets before audiences in Dallas, Boston, Berkeley, and Washington, D.C., in much the same way jazz musicians play together. Over time, some elements in their compositions change. Some evolve more subtly, and some are always new and spontaneous. Here are two comparative variations on the theme, Illuminated Music.
Yeah. So it's a really short example of, yeah, again, Stephen Beck, Warner Jepsen jamming in the 70s, just like they would, like any given modern musicians, like right now. I mean, I feel like a lot of folks you'll see today, tomorrow, throughout the week, throughout the rest of your lives, really, they all kind of jam in this way. Like everyone, I've encountered some folks today that are like, they're interested in, adding some visual spice to their like music playing, music making, and again, I feel like they were doing kind of the same thing here in the 70s. And yeah, it's just like a fun way to like, add some elements and add some movement to what would otherwise be kind of a boring kind of like, yeah, some like random kind of pitch modulation and some sequencing and whatnot have the ability to sound very cool. But I mean, I'm sure some of you guys have also had the chance to see like Autechre live. And for example, they play with no lights, no visuals, no nothing. They let your minds make up the images and the sounds and the visions that you want to see in terms of their own whatever. I mean, Autechre are one of my favorite live acts, but as a visual artist, or like they're one of my favorite like acts of ever. But as a visual artist, there's really not much to see there. And so it's really interesting to be like, oh, why do you like a band that or like a project that doesn't use visuals at all? Musically, it's totally different and unique, but visually, there's really nothing to see. So I try and do my own kind of thing. I mean, when I play out, I use similar devices that you see in front of me. Yeah, like I said, and actually today to demonstrate, kind of again, very similar to what we saw in Warner Jepsen's case. We have a mini little Buchla, the Make Noise No Coast. It's been out for almost a decade now. Somehow still very affordable, very, very fun to use. So yeah, today we're doing our own sort of experiments with kind of based on these motions. I'm sorry we aren't able to have them up on screen for you guys, but I had an issue with the capture card. Again, video synthesis can be a pain in the ass. Because to get the video synthesizer into the computer so you can see it, we have to use things like capture cards that sometimes don't like to work. It's got an HDMI in and a USB connection, and for whatever reason, because of modern what's called EDID standards, some devices are incompatible with others. And I'm going to be salty here for just a second. I hope you guys are all right with that. But yeah, this is just like what happens in video land. I did a workshop last week where I kind of complained in a very similar manner, and I don't know, maybe I'm just annoyed with certain things that maybe Sam had a point. Look, Mom, no computer. Fuck your computers. I only say that because, yeah, like I said, I'm playing with Sam tonight, and I'm using largely my computer. So, yeah. Because, like I said, I flew in from Berlin, and we already have a shit ton of gear to play with and whatnot and exhibit, so we kept it very simple today. So that being said, let's just start with. I'm gonna turn the audio down and go straight to the no coast. We're gonna start doing some audio visualization. Visualize. Words are hard. I'm sorry. Audio visualizations. Audio visualizations. You guys can say that aloud, right? Can we say that aloud? Audio. Yeah, see? It's a bit of a cluster. All right. So I've got this patch set up. It's just a clock going to the contour. So just to trigger the envelope. Hopefully this doesn't sound too awful. It doesn't sound great. There we go. Just a simple kick drum. Bring in some pitch modulation. Yeah, there's a nice kick drum. Cool. Yeah, cool. Great. Amazing. So, we're going to take that kick drum that we've just made, use the end of note to now control I'm going to turn that down, actually. So is that going to work for me? End of note. Am I going to have to amplify it? Maybe the end of note is not what I want. So I'm going to do some voltage math. You guys know about voltage math, right? Cool. Do some voltage math. Take that contour out. Patch it into the mult. I know about modular synthesizers sometimes, I swear. Oh yeah, there we go. There we go. It's buzzing along. Let's use a longer cable. Patch that voltage math. Back into the linear. Okay. Oh yeah, turn the dynamics all the way down. Right on. Cool. So yeah, we have a really simple kick drum moving the oscillator around. Really, really simple, really straightforward. However, though, I'm gonna pretend we have a little hi-hat, or actually, I'm gonna use the slope, the slope in a cycling mode. So, by default, the slope is patched to the multiply, and I can bring that up. So, we're going to take that end of cycle from the slope and now modulate a different parameter within. Now it's modulating the polarization of that oscillator. Yeah. 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 All right. So some really simple audio visualizations. Exactly. Exactly. Really simple. So yeah, if you've got an existing modular, you can do this sort of thing. You can just get one device called Hypno. You can buy an LZX system. You can go that whole route. I think that there are ways to go about it. And it starts to create a bit of a decay on that. So I'm going to bring in the second oscillator. Just button patch. So yeah, that's just doing some feedback. And that second oscillator is, oh yeah, they're FM'd. So you can do frequency modulation. And so now both this kick drum and cycling envelope are interactive with one another. Yeah. They're just creating an interlocked feedback loop. However, though, say we want something that's kind of asynchronous to that motion. I can then hold this oscillator button, and kind of dial in a little bit of motion that doesn't quite match. Bit of variety. Cool. However, though, we've got that gate. We've got a separate gate output that we can play with. I might need to use a longer cable for that. So I can take that random voltage output and patch it to the shape input of the second oscillator. So now that random voltage, is the random voltage doing anything? Oh, it's changing the shape ever so slightly. Oh yeah. Yeah, it's changing the shape. Great, amazing. So yeah, we're going from a noise to a kind of, yeah, something else. Oh yeah, you can do video sampling with Hypno, which is great. So yeah, if you've got one of those, yeah, you can do that. Amazing, right? Stellar. Oh, hold on. Yeah. Huh. Cool. So, you guys have seen how that works. However, though, I'll show you guys another video artist in the 70s, from the 70s I really like. Stana Vasulka. She's a Icelandic video artist. She's presently still alive. I don't know how much video art she's actually making, but it doesn't matter anymore because kind of legendary. And there was a few years ago where I discovered that this actual video example was still presently online. It took a while to find, but we found it anyway. It's called Violin Power, and she's using what is called I believe at the time she was using a Radetra, which is a very long, very well long extinct video synthesizer instrument that you can recreate in LZX, and it's a scan raster manipulator. So it takes a signal and it makes a video feed, and you can stretch it and zoom it and do all kinds of really intricate patterns with it. However, because Stana is a classically trained violinist, she took her violin and sent control voltages from the violin into the Radetra, and this is the result. You guys can see it on screen here, I hope. It's 10 minutes long, but I'm not going to make you guys watch all of it. Yeah, so there's no real audio visualization happening here. She's just jamming on camera. This is how it starts, you know. So, I'll fast forward a bit. Imagine doing this in the early 70s, actually late 70s. Yeah, stellar. So in here, she's using 2 camera feeds, and she's using her violin to switch between the 2 camera feeds. In the late 70s. Sounds a lot like something you could do right now. Yeah, again, 2 camera feeds. Using the violin to just control both. waveforms did. It's like piping an oscillator into a video feed. Alright, I'll show you guys some of the red etcher stuff real quick. Some of the more apparent red etcher stuff. A little harsh on the ears, but you get the idea. Oh yeah, now she's using video feedback. There you see the trail. It says the trail on her. Like video jazz.
C'est moi.
All right. So, yeah, that's Stand of Vasulka in violin power. Again, showcasing these very intricate examples of how to use a very classically trained instrument and a classically trained musician experimenting in the field of video. Yeah, so, let's see, what's next on the docket? Oh, what the fuck? Hold on. Oh, we just watched that. Oh, yeah. So that brings me to Hypno. Hypno is the all-in-one video synthesizer that I'm demonstrating on behalf of Sleepy Circuits, the LA-based company that makes analog-inspired video circuits. It's got full control voltage inputs, full MIDI, full like USB. You can bring stuff in, you can bring stuff out, you can do all kinds of things. It emulates a lot of these old circuits that we saw Stana and Stephen Beck create. So yeah, you can see it on screen currently. It's doing just some really static kind of slanted motion here. It's what we're going to be using to demonstrate some of these techniques in the modern domain. Again, with the no coast at play. So, you guys, again, you guys said you guys don't know too much about video synthesis, and you guys are kind of interested. So we can go over a couple of things. So we just have one oscillator here, and it's being polarized. Let me just fucking hold on. Well, technically now there's so just no. Yeah, we're doing frequency modulation now. We're using one oscillator to modulate the other. Oh, and there's feedback. Oh, yeah, I brought it in. Now it's there. Yeah. Okay. Whoa. We do a lot of this. We do a lot of this in video land, actually, where we're just jamming and we make a bunch of crazy mistakes. But again, it's kind of fun that way. Get some circles, and then yeah, okay. So I forgot what I even wanted to say here. Yeah, there's Hypno. I was doing that thing. But yeah, you guys are probably curious how to actually implement these sorts of audio reactivity things. You guys are probably just like, oh yeah, you could probably like control or just add an audio source, right? You could do that, and it would just be a lot of noise. That's what you kind of saw kind of toward the end there, where it was just kind of noise, and it wasn't really anything like constructive. It was just like and then you kind of saw toward the end where that sine wave shape was actually like modulating the video in a really smooth and cohesive way. However, before you can get something that's like, fully reactive, you need things like envelope followers, for example. I can just go to View, Slideshow, Loading. Cool. So two things to note that like Hypno kind of omits. You can just send it 5-volt audio Eurorack, and it's fine. It's totally fine. But in normal video land, like we see in the Vasulkas and in the LZX system and in Bastion's system, our friend Sintoni, his stuff all works in the LZX 1-volt video standard. Where what this means is, whereas audio stuff only will react to anywhere from 0 to 8 volts, 0 plus minus 5 volts, these sorts of things. Video only works within a 0 or a minus 1 to plus 1 video voltage range. So only 1 volt. It's kind of like an entire octave of video. I believe it's an octave. 1 volt per octave. So you're literally only using a really small amount of voltage to control an entire system. However, you need things like curtail, any sort of scaler, any sort of voltage scaler, 5 volts down to 1 volt. So this module, I'm not sure its current production rate, or if it's in current production or not, but I know there are several manufacturers still producing scaling. Even like if you have like Maths or like Cascade, I know like one of Tom Whitwell's old modules, still use that all the time actually for this sort of thing. Just to scale and attenuate. You just want to scale down the voltage and make it work in the video system. However, though, a friend of ours, Nick, formerly Brown Shoes Only, now Video Headroom Systems, makes a module called Aural Scan. It's a three voice envelope follower. So lows, mids, highs, and you have level for each control and a slew. So you can make it kind of sharp and percussive, or long and slow and droney, and you know how when you want to make a string patch or you make a percussive patch, you use a slew limiter to control the amount of, if it's short and percussive or long, and just like a dedicated audio envelope. However, Aural Scan has a few tricks up its sleeve. There's a built-in scanner circuit. You can use it to mix video signals on top of modulated video signals. This is how you get really tight, precise modulation or audio reactivity. Hey, there it is again. That's how you get really tight motion in video land, in video synthesis. However, I think a lot of this is fun and all, but again, I think the best practice actually is to just jam. You just you tune your oscillators, you tune your instruments, you both kind of you kind of fumble and make some mistakes and whatever. I think that's the more interesting way to go. At least I find, because when I try and do really tight stuff, especially I played a gig in Poland last week, and they sent us. I output my computer to a wireless HDMI transmitter, and for a moment I wanted to do some really tight audio reactive stuff, and I found that because it was a wireless transmitter, there was some degree of latency. And that latency would cause some really weird offbeat kind of stuff to happen. And it was kind of cool if you threw enough feedback on top of it. Great. However, there were moments where it was kind of awkward and weird. And I was just like, why is it reacting so slow? It's like, oh, right, there's a delay because it's wireless. So I think using these really tight motions, is sometimes impractical. Because, yeah, like I said, musicians fumble, you fumble, your brain, you get a bit of a headache, and you don't really know where to, like, go or take things or whatever, you know? So, yeah, we'll slide to some detail. Yeah. So, oral scan, VHS, video headroom systems. Yeah, 3-band envelope follower, designed with video synthesis in mind. Thanks for coming, y'all. Y'all have a good one. Uses an onboard mic and preamp for instant access to the sounds around you, but allows you to patch mono in directly for the 3 inputs, low, mids, and highs. Each envelope is fed into the scanner subcircuit where you can map the low, mids, and high animations to different parts of your screen. However, each envelope is also sent to a video rate mixer, allowing you to add extra bits of video for your main outs. So I should add some context here. This initial workshop concept series, or this initial workshop itself, was derived from a series of video workshops I did at Schneidersladen. So there will be some bits where, you know, it's just like, oh, what does this have to do with Hypno? It's like, it's kind of part of the initial workshop as a whole. So this module was mentioned because at the time, and I believe it's still in production. It's only been a couple of months since then, but it's still in production. You can buy it at Schneidersladen. You can buy it wherever LZX and video synthesizer modules are sold. So yeah, these are tools that you can have access to today, maybe tomorrow, maybe honestly probably next week if you, yeah, fingers crossed, if shipping and customs and all that jazz work out. Or we can just do it in Max or Resolume or whatever you like to use. This is a little bit of detail about Curtail, but it's really, again, just some higher, kind of more spec level, more what is the word? More detail on the scalar module or the concept of a scalar module. I said it aloud, but yeah. So 4-channel voltage scalar that scales plus minus 5 volts to Eurorack video, 0 to 1 volt. And I should actually say this. Our friends at Bella, they're kind of just across the hall here. Special for me, apparently, they made they make the module called Gliss. It's the touch module, the touch plate module. I asked pretty please, and they gave me a 1 volt scaling option, which I'm pretty excited about. I'm really glad that, like, you know, they listen to artists and they really appreciate, like, you know, the concept and people that want to use it, not just for audio stuff, but for video stuff too. So things that you can do this in Gliss, which is amazing. But yeah, Curtail refers to the approach popularized by LZX Industries to network audio and video modules within a system. Even with higher output voltages, the modules reduce the levels by a factor of 5. So plus minus 8 to plus minus 1.6 volts. Using a high-frequency operational amplifier, a wide frequency range is covered and ensures efficient communication between both worlds within hybrid setups. So yeah, that's the thing. Like, video stuff is very niche, very like, you know, specific in what it wants. You can turn anything into video. You can turn anything into valid video as long as you have the right scalars and the right kind of output encoders. Anything can be video. But if you want something that's kind of tight and like this and precise, you got to use the right op amps. You got to use the right, like, conversion methods. It's a whole workout. And so it doesn't surprise me that, like, most folks aren't really grasping onto it in the same way that me and several others have. And honestly, the cluster of video artists that are here tonight is actually pretty promising. So I'll say that. Is that another video? Or is this a blank slide? Or did we go out of Wi-Fi? Oh, that's scanners. Oh. Is that the end of the slideshow? Yeah, I guess that's the end of that slideshow. However, let's hop over to Resolume. Resolume is the de facto VJ software. Anyone that considers themselves a VJ or a video artist, they all have some access degree of Resolume. I just want to show you guys a couple of parameters within Resolume that lets you do audio reactivity. So I have this patch that I made in MaxMSP, a software within MaxMSP called vSynth. It's a virtual video synthesizer for Max. It emulates all the classic video synthesizer circuits, but in a software realm. It's really nice. I really enjoy it. However, though, in Resolume, you can add all kinds of effects, and you might be able to see this. There's an effect called terrain, and you guys can see what it does. Just kind of, it makes the video look like it's like scrolling through a sort of mountainous terrain. However, though, this is an effect I like to use a lot. There's this parameter called tilt, and if I, is it, haha, sick. Let's see, preferences. Again, video stuff is fun. Maybe you should do it, maybe you shouldn't. It's up to you. Microphone array. Microphone array. Audio output device. Pray this works for me later. Whatever. Motherfucker. External FFT. This has worked for years. I don't really understand why the fuck today it's just gonna fuck up on me. Microphone array. That's what we have. Outputs of 1 and 2. Input channel 1 and 2. Is there some sort of I just had to do video. I just had to show you guys all kinds of things that are cool about video, but also like not very fun about video. And I feel like it's an important thing to like kind of show you guys because you think stuff's just gonna work out, but sometimes it doesn't. And whatever. Why is this not? Are you fucking kidding me right now? Oh, there it is. I just didn't have the gain turned up high enough. Okay, so now when I speak, oh yeah, usually, you guys have been to clubs, you guys have been to venues, you guys know how loud that shit can get. You guys can clearly hear how loud I'm getting right now. Oh, cool, we have Wi-Fi again. Pray to God this works. Maybe Spotify. I'm sorry I use Spotify, guys. It's not the nicest thing in the world, but just have like a documented. Turn the volume down. Okay. So this is my friend Cult Member. He makes some nice tracks. Is that gonna work? Yeah, I hear something. Cool. It's just kind of low. What's that? Okay, cool. There's some sound. There's some lo-fi shit going on. So yeah, now that tilt is reacting to the video, reacting to the audio. You know, it's really tight audio synchronicity. So, and I use this feature a lot when I've made a track or like I've made some visuals, and I actually use this project a lot actually for the last few years. Just kind of continuously adding to it, removing stuff. Sometimes I make some really tailored, specific kind of things for artists and bands and stuff. But this is my general kind of working project. And so if I have a visual that I like, and I don't really know what the music's going to be like, or I can just throw a usual effect on there, this kind of effect on there, and it's always going to be in time, and I don't really have to necessarily think about, oh, is it going to work for this artist, or is it going to be this, or is it going to be that? I just find that, yeah, if I throw some audio reactivity, most people don't really seem to mind, or most people don't really think that I don't have to really, it means that I don't have to stretch myself super thin. It means that I can focus more on having a good time instead of stressing about worrying if everything is in sync or not. And so just throwing little effects, like audio reactive effects on the tilt, and you have a full envelope follower on this as well, so you can make it really tight, percussive, these sorts of things. It's also occurring to me that we are at are we at 3:26? Have I been here for almost an hour? Yeah. Yeah. Yeah, it's 3 in the afternoon, 3:30. We've been here almost an hour. I probably glossed over and forgot to talk about a lot of things, but I should probably open it up for questions now. If you guys are down for that. So, yeah. Yeah, do you guys have any questions? Any thoughts? Yeah. 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 Oh, on Hypno. Yeah, totally. Totally. So, with Hypno, you can load video samples in via USB drive, this little thumb drive sticking out. And if I change the oscillator until it turns teal, let me actually just go to a plain preset. Oh yeah, there we go. So, yeah, I developed a preset that just does plain video sampling. You know, you load a clip onto a USB drive, and to cycle through those, well, before we cycle through them, I'll show you guys a couple of things. And so we have that effect here. Let me bring that really boring kick drum or whatever. So yeah, we're just using a clock to do this sort of thing. You guys know what that does. Yeah, really simple, really plain. But yeah, you can apply that to the rotation or whatever you like. So this is just some leaves, some footage of some leaves, some foliage, doing a thing. And I can cycle through that by holding two buttons, like the oscillator and the feedback button. Let me actually kill that because it's not really nice to see. I got myself tangled. So again, there's some more footage of some foliage. And then you can load like lots of video samples on here. So if I hold those two again and hold this this knob right here, it's usually the polarization knob on the oscillator. Turn the feedback down. So this is done with oscillographics. Again, just plugging a modular audio signal directly into an oscilloscope, or in this case, a Vectrex console. And I've got these like animations going. So again, like a really weird direct audio visualization. And yeah, I can load all kinds of things. I can play back some glitch stuff that you're probably going to see tonight. Oh yeah, some crazy video distortion. Some more video distortion. So you can use it in a lot of ways like you would in Resolume, where like I'm literally resampling myself. Like this is 5-6 years worth of work right here that you're looking at in front of you. And you can use Hypno in the same way you can in Resolume. We're looking at weird parallels. I mean, one runs off a $1,200 gaming computer, and the other runs off a $40 Raspberry Pi or whatever. So take your pick. I mean, Hypno is limited to like standard resolution like NTSC and PAL over an HDMI connection. So the inputs are rather small. Or the you can't quite do HD stuff, but yeah. So yeah. Does that answer, or have we gone into the void? Cool. Amazing. Yeah, no, totally. And if you want, we can talk more about it at the booth, however long you like. So yeah, if you guys have any more questions. Yeah. So if you're familiar with audio synthesizers, there's an envelope generator. Yeah, and so that can be used to the concept of an envelope follower is to take an audio signal and use an envelope to shape how the audio actually affects the signal. So if I want it short and percussive, I dial it in as I would just an attack decay, or a sustain release. If you want something that's like long, get a long release and something to affect over time, like you can see it here, the fall time. If I increase the fall time, you can see it. Exactly. Yeah, exactly. Yeah, it's just a really precise way of dialing in the modulation. So, yeah. Yeah, of course. Yeah. Yeah. If that's it, or y'all are welcome to come hang out, do your thing, go see more video, go see more synthesizers, however you like. So I'm probably gonna call it here. So yeah, thanks for hanging. I'm sorry I fumbled a lot and made a lot of weird little zones and mistakes, but yeah, I hope that kind of showed you guys about video synthesis and video art and everything it takes to make a lot of mistakes. And yeah, I don't really know what the fuck I'm saying anymore. Excuse me. Yeah. Thank you.